Hello, welcome to the Flat Earth Institute of Science. Our public debate board has been a great success. It is continually growing and a lot of great points are being made on both sides. It is most certainly not an echo chamber. In fact, there are currently more anti-flat earthers participating in it than there are flat earthers. With that being said, I would love to see more flat earthers come and be a part of it. There's a link to it in this video's description. Anyway, I would like to publicly recognize one of our participants, Night Sky Jeff. Even though he is very much a globe earther, he is a sharp guy and has pointed out something I didn't notice before concerning Rob Skiba's Setting Sun video. In his video, Rob Skiba highlights a news report where a professor from Notre Dame University used a magnifying glass to demonstrate how the atmosphere refracts light downward as it travels through the atmosphere.
The science is the same of that of a lens. Here's a simple example.
So if you're looking at Chicago here, just maybe now you can just see the top of the Sears Tower, and if our simulated temperature inversion moves into place, hopefully now you can see pretty much all of Chicago,
see all the lower buildings,
including with the ground level.
So the atmosphere really is acting like a lens.
Yes.
Rob Skiba then used his own lens to demonstrate how the sun can appear to set on a flat Earth due to atmospheric refraction. Now this is what Night Sky Jeff was able to point out to me that I didn't notice before. Here on the left, the professor from Notre Dame used half of a magnifying glass to perform his demonstration, while over here on the right, Rob Skiba used a full magnifying glass to perform his demonstration. This has caused me to go back and rethink things. Typical magnifying glasses use convex lenses, and this is how a convex lens works. The top half refracts light downward, and the bottom half refracts light upward. So in Rob Skiba's demonstration, he used both upward and downward refraction. Now, if a full magnifying glass is supposed to represent the atmosphere, then the atmosphere would have to be thin at high altitudes, dense in the middle, and then thin again near the ground. That is not what we observe in reality. That is why the Notre Dame professor only used the top half of his magnifying glass. But I'll point out here that there is something wrong with his demonstration as well. Magnifying glasses use a radial gradient, wherein they are thicker in the middle and then they get thinner all the way around. The atmosphere doesn't get thinner when we look left or when we look right. The atmosphere has a vertical density gradient, not a radial one. So this most certainly calls for a new, more accurate experiment and demonstration, as good science demands. Alright, so here is one experiment we can do. We can create a vertical density gradient in some water by pouring a bunch of sugar into it and letting it dissolve. Here we have a person shining a laser beam into the water, and we can observe that light getting refracted downward. Now if we were to put a picture on the other end of the tank of the sun or a city, the question is, would that image appear higher or lower than it actually is? Now is the time to form your hypothesis. Please note how many people out there frequently claim that downward refraction should cause things to appear higher than they actually are. Here you can see this claim being made by timeanddate.com. Here, a YouTuber by the name of Mick West was able to perform this experiment for us. Now Mick West is a globe earther, and please note how here he put a curved piece of metal in his fish tank to represent the curvature of the Earth. With that addition, what we are still going to look for is, does the city look higher or lower after the sugar is added to the water?
So first of all, I'm going to do it without sugar, then I'm going to add sugar. Now, when you add sugar, what you do, you fill the tank with water, then you pour sugar in so it lays in the bottom. the sugar at the bottom starts to dissolve, and that makes the refractive index, the density, essentially the optical density of the water, will be higher lower down, and light bends towards a more dense medium, which is what normally happens in the atmosphere because the air is denser lower down. So you should see the light curve downwards, and we should, looking at this end, see more of Chicago from this end. So let's see what happens.
So what do we see here? We see the same view of Toronto that we saw before.
It is magnified, of course, but it's not distorted in any way. The image is exactly the same. It's just bigger because we're looking through the water.
Magnified? That's an interesting observation. That sounds like what Rob Skiba said.
So I've got about 6 gallons of water in here, and I'm going to add around about 5 pounds, I think, of sugar.
One thing I didn't take into account was that it was very, very cold in my garage, so it took a really, really long time for the sugar to dissolve, and I ended up moving the fish tank inside.
5 pounds of sugar. So what I ended up doing was removing some of the water and just lowering this curve a little bit because it was a little bit too much for my needs. But what actually happened was it worked. The water dissolved the sugar and we get a bending laser beam. Now, it's most obvious if I kind of point this laser beam upwards a bit and then move the beam down, 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 and you'll see as we get to the bottom here, it bends over at the far right hand side. And that means if we're looking up in this direction, if you have a camera here, which I'll put there in a second, the line of sight from the camera will go up, over and down, which means it will go over this obstruction here. If you see, I send this light beam out and it actually bends down right over the other side. It actually goes over this little lump of metal I have here, which I used to raise the obstruction because I flattened it a bit too much, and it comes over the other side. So what can we see at the other end? Well, at the other end of the tank I have a picture of Toronto, not Chicago. And the interesting thing that happens is when I move the camera down, so it would normally be obscured by this curve and this block here, instead of being obscured, the distant image of Toronto actually seems to get compressed and rise up in the air. All the way down. And you can see it's being compressed. Up again, it's back to normal. Go down, it's compressed.
Alright, so did the downward refraction cause the city to appear higher or lower than it actually was? The compression most certainly made it appear lower than it actually was. Sorry, time and date, you guys got it wrong. This supports the flat Earth. Now here in another video, Nick West is going to show us what happens when we remove the curved piece of metal and view the city across a flat plane.
So could refraction make a flat Earth look like it was actually round by making things appear to go below the horizon? Well, if we move the camera down, you can see that it kind of looked like things are going behind the horizon. But look at the laser spot that I put just right on the bottom of the skyline of Toronto there. If you go down, you'll see the laser does not disappear behind anything. In fact, it stays visible all the way down until we go off the bottom of the aquarium. You can actually see it still visible when we're right down to like a fraction of an inch above the ground here. And you can see the actual skyline of Toronto has been completely distorted there.
Wow. Now with enough distance, I'm certain we could get that entire skyline completely out of view.
But it's all actually still there, as you can tell, because that one laser spot is still getting through over this flat section of the tank.
Refraction happens mostly when you're looking through a curved gradient. And that's not going to be happen when you're looking straight up into the sky.
Curved gradient?
Yes.
Okay, so we just looked at the whole fish tank experiment,
Yeah,
right? With the
and
sugar.
he had the curved gradient in there.
That wasn't a curved gradient.
Of course it was. He had the curved surface.
Over this this flat section of the tank.
And then it would have, the curve
Fish tank
would
on a
have,
curved surface?
yeah, he put the curved surface in the bottom, like you said, to represent the curve of the Earth.
The curved surface wasn't affecting the refraction.
Of course it did. That's the entire point. The curved surface will make the gradient of density also curved above it. It's the curve that causes that refraction, because when he took away the curved surface, the laser and the background were just, straight but a bit more magnified, and the laser was going straight.
But it's all actually still there, as you can tell, because that one laser spot is still getting through over this this flat section of the tank. Now, over the curved section with the obstruction, you get the same type of thing, except here we do actually get the light disappearing behind something, because there's actually a physical barrier here, an actual physical curve. If the ground was flat, there's never anything that's between you and the light, so there's always going to be some path to that light. So if you've got a very bright light, and if you were on a flat plane, you would always be able to see a light. But on a curved surface, or a surface with obstructions, yes, as long as it's got enough of a curve or enough of an obstruction, you will actually see the light being extinguished.
Now, Mick West just said that he believed if the Earth was flat, the light from the laser should be able to go on forever, even though it would be getting bent downward by the atmosphere. I hope you see the error in that logic there.
It's between you and the light, so there's always going to be some path to that light. So if you've got a very bright light, and if you were on a flat plane, you would always be able to see a light.
Since the light is getting bent downward, it will eventually crash into the ground, and when it crashes into the ground, it will lose the ability to go on forever. Here, the crazy Russian hacker was performing the same laser sugar experiment, and you can see the light hitting the bottom of the fish tank before it reaches the other side. If the bottom of the fish tank were not so reflective, that light wouldn't bounce up and reach the other side, and a person over there would not be able to see the light at all. This is how night is able to happen on a flat Earth. And there you have it. Now, if anyone would like to join our public debate board, we've got a link in this video's description. It's totally free. So, we hope to see you. Thank you for watching.
It's the curve that causes that refraction, because when he took away the curved surface, the laser and the background were just, straight but a bit more magnified, and the laser was going straight.
Look, you can see the light there much better. So I put sugar over there, waited till it dissolved and settled down. So all the sugar water is on the bottom. Now let's see what happens if I'm gonna set the laser all the way down. Boom, look at this. Pretty awesome, huh?